Are you looking to learn about data security architectures? If so, this video is for you. Hi, my name is Mike Gibbs. I'm an enterprise architect with a little over 25 years experience. And in today's video, we're going to talk about data security architectures and data privacy. And when it comes to data security architectures, we're looking for a few things. One is to make sure that confidential information stays confidential. Two is to make sure that information hasn't changed. For example, if we have an electronic health record, we don't want someone to change the dosage of a medication and cause patient harm. And of course, the other thing that we're typically trying to protect, amongst other things, is exfiltration or data leaving the system. So that's what we're going to talk about today. So we're going to talk about the components that you can think about from a security architecture perspective or a data privacy or security architecture perspective. And we'll break it down into several components. The first component I'm going to talk about is making sure you don't have too much data. And that's called data lifecycle engineering. And let me explain what I mean by that. There's going to be a point in time in a business where the data that they have, some of the data they've collected, is no longer useful to them. And keeping that data open and available means that even if it's not useful to us, a hacker could still find it and get access to that data, which increases the risk of a breach to us. So don't hold on to data that you don't need. So typically speaking, especially in a cloud computing environment, we have different storage tiers for our data, a storage tier for things we use every day, a storage tier for things that we typically use periodically, and then a storage tier for things that are going to be backed up for a while. We definitely want to leverage them. And when we have information that's no longer useful for us, let's get rid of it. So keeping track of not having too much data in the wrong places, let's talk about tokenization. And tokenization is going to be another way where we can actually protect privacy. So what is tokenization? Let's say we've got a real information sitting inside of our application. Let's say a credit card number. Well, we don't want anybody being able to see your credit card numbers on the screen. So you may notice that there's typically some tokenization there where you see some stars or you see some X's and then you only see a few numbers. That's tokenization. The reality is we've got a centralized token service that's there that's being able to swap the tokens with data, and it knows it, but it's nice and it's absolutely secure. So that's one way, and that's loosely explained how that works. So if we're going to make sure we do that, we also want to make sure that any kind of data that we have is minimized in the shape. And there's other data privacy techniques we can also do, things like anonymization or pseudonymization. But whatever we want to do, we want to make sure it's very hard to hackers to even be able to access the information. If they get it, we want to give them as close to worthless information as we can. So that's the data lifecycle, data privacy things that we're typically going to talk about. Now, what comes next? Encryption. And we're going to talk about a lot of encryption. So obviously for anything stored, like on our drives, for example, in file storage or in block storage, object storage, we want to encrypt that. And we want to make sure that if anybody were to steal the hard drives, for example, they couldn't get access to your information. We want to make sure everything is encrypted. So if you don't have the decryption key, you can't get access to the data. So encryption at rest. Now, TLS everywhere. Now, what does that mean? Anytime data is in motion, we want to encrypt it, and TLS is perfect for that. So we can typically use TLS encryption from point A to point B along the way, and that means that that data can't be compromised along the way. Plus, encryption does a few other things for us. Encryption, like TLS encryption, says if we have Bob and Bob wants to talk to Sally, encryption will make sure that Bob and Sally are who they claim to be. It will also make sure the message hasn't been changed along the way. So we get a couple of really great things along the way from encryption. So we're typically going to encrypt everything because it proves that the endpoints are who they claim to be. Now, going along with encryption, we can do things like service mesh as well. And basically what we're doing is we're just encrypting everywhere anytime things are moving. Now, let's talk about some other kinds of encryption. We're going to talk briefly about some homomorphic encryption and where we typically use that. And homomorphic encryption enables us to compute on encrypted data. or split our computations across some other environments as well. And why do we want to use something like this? Well, if we have to decrypt the data before it gets in memory on the CPU, well, potentially if we've got multiple things running on that same server, but there's a theory they could get access to some of the data while it's unencrypted in the CPU. But if it's encrypted and we can compute on the encryption with homomorphic encryption, that puts us in an environment we never have to have decrypted information. Which now gets us into what's called confidential computing, where we've got a trusted execution environment, and that way we're protecting the data inside the hardware that we're actually using in the hypervisor level. And by protecting the data at that hypervisor level, we're actually protecting the data should a breach occur going from one system to another system. It should never happen in the first place, but it gives us some protection against that. Now, if we're going to have encryption everywhere, we need to somehow have a very strong key management system or some way to manage the key. So we'll need a very good key management system that we're typically dealing with, because we're going to have to manage our secrets. We're going to have to constantly manage credentials, what have you. And we want to use some kind of secret management system that's got very short-lived dynamic credentials. So if server A talks to server B now, potentially whatever the credentials are different 30 minutes from now or an hour from now. And that way, if a hacker were to get access to those credentials, they can only use it for a short period of time. Now, what else do we need to protect our data? A very strong identity and access management system, something that is much stronger than just role-based. Your job enables you to do this. Typically here, we want to get into some context-aware IAM or some attribute-based IAM or policy-based aware. And what we do want to do is make sure we limit the capabilities of the person. So we can determine who the person is. Are they coming where they're supposed to be? Are they coming at the right time of day? Are they coming in the right device? We can determine what they've done or limit what they can do, and then we can log it after the fact for auditing purposes. So we need a very strong IAM system here. Now, we have to keep track of what's going on. So we need to have some form of logging that's tamper resistant. And how can we do that? We can make sure the logs are signed with a hash. And if you're familiar with one-way hashes, the data will become a single hash, and we can use that hash to actually prove that the data is what it was. And we can never go back from that hash to the data. So typically some kind of tamper-evident logs with some kind of hashing along the way to make sure these logs have not been changed. Now, another component we definitely need to have for our data security are backups, but I typically like immutable backups on write once, read many times storage. And here's the reason why I like immutable backups and immutable object storage, because nothing can change. So if you have your data and ransomware were to try and encrypt it, it can't encrypt it on immutable backups because immutable backups can't change. So typically speaking, we need to have some very good backup strategies to make sure that we're protected against any type of ransomware, but also any kind of data loss as well. But those backups need to be protected very seriously and obviously encrypted along the way. Now, when it comes to data, we don't want it leaving our systems. We don't want it being exfiltrated and used by hackers. And that means we need to use some form of a data loss prevention strategy. Typically, the egress of our network or any leaving points, we monitor traffic with a data loss prevention system and block it. But we might also want to use data loss prevention systems on the servers themselves, depending upon where they are. Some organizations get so crazy about it, not only do they use data loss prevention software, but they'll break off even USB ports on side of the computer so the users couldn't actually connect a USB port to actually copy data, even if they wanted to, in the event that the data loss prevention software would prevent them. So we typically need a very good, strong egress control from a data loss prevention strategy at bare minimum. And of course, any of our administrators or people that have better access to this system, we need a very strong phishing resistant type of multi-factor authentication for those power users, because we don't want getting access to the very strong credentials and the strong permissions that those users have. So we need something there. Now, in today's video, we talked about data security architectures. Now, this is not an enterprise-wide security architecture discussion. It was more about data privacy architectures and data security architectures. And we talked about how to secure your systems. Now, if you'd like to become a security architect, an enterprise architect, a cloud architect, or an AI architect, come join me on a free architecture webinar. We run them 1 to 2 times per week. On these webinars, we'll talk about what is a cloud architect versus a security architect or an AI architect. What do we do in and our architect roles, how to get hired, and everything you'll need to know about how to become a security architect or how to become an enterprise architect. These webinars are free. They're on Zoom. You can ask me any questions, and I'll love to do anything I can to help you on those sessions. And they're free. So you can register for a free architecture webinar. The link is in the description of this video. If you enjoyed this video, please give it a like, subscribe to our channel, and hit the bell to be notified of new videos to assist you in your architecture career. This is Mike Gibbs signing off for now, and I hope to see you in another video real soon or a free webinar. Take care.